Chapter 5 for Business Finance. In Chapter 5, we continue our discussion of the time value of money. In Chapter 4, we looked at the time value of money concepts and lump sum amounts. In Chapter 5, we're going to be looking at individual amounts and annuity amounts, so yearly amounts. There are multiple ways to calculate cash flows. We can use time value of money formulas like we did in chapter 4. We can use a financial calculator such as the Texas Instruments VA2 Plus. You can use a scientific calculator and you can use Excel spreadsheets functions. You can also utilize time value of money tables like we practiced in class. If we're looking at the future value of money for multiple cash flows, so in this example, we are able to deposit $4,000 at the end of each of the next 3 years in a bank account that pays 8% interest. Today we have $7,000 in the account. So how much will we have in 3 years and how much will we have in 4 years? So we need to look at each one of the amounts. So today we have year 0 is our $7,000. So that amount we're going to earn 3 years of interest on at 8% interest. So the future value of that $7,000 is $8,817.98. Then we have each one of the 4,000 year payments. So in year 1, at the end of year 1, we pay 4,000, so that earns 2 years of interest. At the end of year 2, we put in another 4,000. That is going to earn 1 year of interest. And then at the end of year 3, we put in an additional 4,000, and that 4,000 isn't going to earn any interest at the end of year 3. So our total value of the money we had in there plus those 3 equal cash flows of $4,000 at the end of 3 years is $21,803.58. After year 4, that amount of $21,803.58 will have earned an additional year of interest at 8% and will then be $23,547.87. If we deposit $100 in 1 year, 200 in 2 years, and 300 in 3 years, how much will we have at the end of year 3? At 7% interest. Or how much in 5 years if we don't add any additional amounts? So at the end of year 1, we have $100. At the end of year 2, we put in $200, and at the end of year 3, we put in $300. The 100 earns interest for 2 years. The $200 earns interest for 1 year, and the $300 doesn't earn any interest at all at the end of 3 years. We then have an additional 2 years where we don't add any money that collects another 7% of interest. We can look at how that happens via a timeline. So we can put those amounts on the timeline. At 0 timeline, that's today. Then the dollar amounts that we put in are at the end of each year. So at the end of year 1, we had $100. At the end of year 2, $200. And at the end of year 3, $300. And so we can see how each one of those collects a different amount of interest because some of them are in there longer than others. This is also a future value calculation where we look at, this is the same exact information from the previous slides, looking at the calculations that we can use in Excel with the future value calculation. So at year 3, we would have $628.49. If we left that money in for an additional 2 years, it would then have a value of $719.56. What if we invested $500 in a mutual fund today and then added $600 in 1 year? If the mutual fund pays 9% annually, how much will we have in 2 years? We have that $500 collecting 2 years of interest and the $600 collecting 1 year of interest. If we make no more deposits but leave that money in for 5 years, then the $500 earns 5 years of interest plus the $600 earning 4 years of interest. The other way is to just use the value at year 2 and add 3 years of interest. So there are multiple ways, much like when we had in chapter 4, there are multiple ways that we can do those calculations. What if we plan to deposit $100 into account in 1 year and then $300 into the account in 3 years? So at the end of year 1, we put $100 in. At the end of year 3, we add another $300. How much will be in the account in 5 years? The $100 is going to earn 4 years of interest, and the $300 is going to earn 2 years of interest. So we add those two calculations together in order to get the future value. We can see that on this timeline here, that at the end of year 1, we put in the 100. At the end of year 3, we put in 300. So we have 4 time periods for interest calculation for the $100 and 2 time periods for the interest calculation for $300. What if we look instead at the present value of multiple cash flows? So we're offered an investment that is going to pay us $200 in the first year, $400 in the second year, $600 in the third year, and $800 in the fourth year. We can earn 12% on a similar investment. So how much should we be willing to pay for this investment? Well, the present value of those cash flows added together is $1,432.93. And we can see on the timeline here. So the 200 is 1 period, the 400 is discounted at 2 periods, the third payment of $600 is discounted at 3 periods, and the fourth payment of $800 is discounted for 4 periods. Annuity is a finite series of equal payments that occur at regular intervals. We can get monthly payments or yearly payments. Say if we have a retirement account, that is an example of an annuity where we receive money out of our retirement account every single month, and it's an equal amount. If the first payment occurs at the end of the period or the last day of the period, it's an ordinary annuity. If it occurs at the beginning of the period, it's called an annuity due. A perpetuity is an infinite series of equal payments. That's when somebody comes to you and says, I'm going to give you $100 a month forever. That is a perpetuity. There's no end. An annuity is a finite series, so it's either going to be 10 payments or 30 payments or 100 payments, but there's a definite amount of payments. The basic formulas for annuities and perpetuities. Perpetuity is the present value of the payment divided by the rate. For annuities, we either have the present value or the future value. So we see these are very similar to our future value calculations, except that we've added in that there's a regular payment. So PMT equals payment, R is rate, and T is time, the number of time periods or time calculations that it occurs. The calculations in Excel, we would have the number of payments and then that 0 or 1. For the 0, that is at the end of the period or an ordinary annuity. The 1 is used for an annuity due, when payments happen at the beginning of the period. Important things to remember are that the interest rate and the time period must match. So if we're using an annual time period, saying 7 years, then we want a rate that is an annual rate. If it's a monthly time periods where we say every month, then we need to make sure that we're using a monthly rate and not a yearly rate. We also need to think about the sign convention. We need to make sure that cash inflows are positive and cash outflows are negative. This example of an annuity. We can afford $630 a month as a payment. So we want to save up, maybe we want to buy a car or buy a house, and we know that we can pay $632 a month. The current rate is 1% a month for 48 months. So how much can we borrow? We need to borrow money today, so we're going to look for the present value. This first information here is how it would be typed into a financial calculator or a scientific calculator. This here is the formula if we do everything by hand. Our rate is 1, our time periods are 48, our payment is 632, giving us a present value of approximately $24,000. Or in Excel, we have the present value with the rate of 1, time periods of 48, the payment as a negative number, 632, and 0 being at the end of the period. It's a normal annuity. Okay. What if we won the lottery and it was a $10 million sweepstakes? And you often hear from the lottery that you can take a lump sum or an annuity. If you take the lump sum, the total lump sum is the present value of what the annuity would be paid over a number of years. So if you get an annuity, you are paid $333,333.33 a year every year for 30 years. If you decided to take the lump sum, that present value of that would be $5,124,150. This is why when you see the lottery figures, what the lottery says it is often has a little disclaimer underneath that says what the lump sum payment is, because to get the full amount, you have to take annuity payments over a series of years. What if we were looking at buying a house? So we're looking at buying a house. We have $20,000 down for a down payment and closing costs. Closing costs are estimated to be 4% of the loan value. We have an annual salary of $36,000, and the bank is willing to allow our monthly mortgage payment to be equal to 28% of our monthly income. The interest rate on the loan is 6% per year. That's monthly compounding at 0.5% per month for a 30-year fixed rate loan. So how much money will the bank loan us? How much can you offer for the house? So we're looking at our monthly income. So we take our yearly income and divide it by 12 for $3,000. Our maximum payment is 28% of our monthly income, so $840. Our monthly interest rate is 0.5. And we're looking at 360 months for 30-year payment. So we have closing costs, or the total price, at an $840 payment, the present value of that amount is $140,105. So when we look at the closing costs are 4% of that, that means that closing costs are $5,604, leaving us a down payment of $14,396. That means that the total price that we can offer for a house and have a monthly payment of $840 is $154,501.